Welcome, students. As you understand, the title is Introduction to Airplane Performance. And before I start this course, or try to share what I have learned, let me tell you a story. I was staying in Delhi during my childhood in a place called Humayunpur, which is very close to the airport. And every morning I used to see airplane flying over my house. And at the best I could think, I could wish was, can I get a chance to board this airplane? Can I get a chance to travel using this aircraft? It was a very difficult wish because so far till that time I have seen film actresses, they are moving in airplane, rich industrialists moving in airplane. So it's almost like you will get never a chance to board an airplane. But the destiny has something else to say. One fine morning I joined IIT Kanpur in '77 in aerospace department, and I thought I got a golden chance to board an airplane. And it was in '78, first time I could sit in an airplane, and that airplane is still with us in our hangar, which is Flight Laboratory IIT Kanpur, and that aircraft was Cessna 182. We'll show you that airplane. But let me tell you honestly, all those excitements were not there. This airplane didn't have an air hostess, it didn't have a stewards, it didn't have all those luxury which I used to see in a movie. Moreover, it was a course flying. That is, we are supposed to do an experiment, but the pressure was on doing experiment, but the fun part was missing. And after that, I joined Defense Research and Development Organization, where nowhere aircraft was seen where I was working. It was missiles, it was rocket, artillery rockets, aircraft bombs. So I was too far away from aircraft. And I was sure that my desire to be near aircraft was almost vanishing. Again, as destiny has to play its role, one fine morning I found I have become faculty in IIT Kanpur, and I was the faculty in charge of this hangar, which is Flight Laboratory, and we had 4 or 5 aircrafts surrounding me. And for the first time I realized, after doing BTech, MTech and PhD, I hardly understand aircraft. And it's nothing surprising. That is, common thing happens with most of the aeronautical engineers who are getting degree. So first lesson which I learned as a student, as a teacher, I must see an aircraft closely and try to appreciate what has gone into an aircraft in terms of system, in terms of components, in terms of instruments. So we'll have one demonstration to you where we'll be showing you all the aircraft with all the parts, explain you why they are required. But before going to that, I come back again to this topic, Introduction to Airplane Performance, and I will underline 2 words. One is airplane and there is performance. Let us go back to the fundamentals, whatever we have learned at the class 11th or 12th. If you recall, if there is a body of mass m, and if I eject it with a velocity v and at an angle theta, I know that this is typically example of a projectile in motion, and smartly you can draw this path, and we'll say the projectile or the mass will follow this path. And this is typically a projectile motion. What actually happens here? As I launch this body, there is a gravity, which is mg, which tries to pull this body, and this body has a velocity v. What is the effect of this force on this velocity? Let us again go back. Example, a very popular example. When I move a stone using a string, could see that this body will move in this direction. What is happening? The velocity vector, this velocity direction is changed. And who changes this direction? The tension in the string. So now, if I again come, there is a velocity vector and there is a force, gravity force pulling this body down. So you expect, as happened here, the velocity vector changing direction, and at some point it will hit the ground, right? But if I want to design an airplane, I do not want this scenario. What do I want? I want it should go something like this, sustain for some time, and come down. This typically I will look for such a motion of the body. If I want to do like this, what should I have? Whatever gravity force is trying to pull this velocity vector, I need another force which should counter this velocity or counter this gravity force, right? Somehow I have to generate this force. If I could generate this force comparable to this force, then turning of this velocity vector will be minimal. And if I balance it, then there won't be any turning. It will go straight, right? With this idea, to generate a force so that I can move for a longer distance, initially the concept came, if this is the body, I put some blade here, some propeller, and that propeller will generate force, and this should be able to compensate the gravitational force or force of gravity acting on the body of mass m. This is typically the concept behind what? This is a concept behind designing of helicopter. Okay? But most of the part, when we talk about airplane performance, we will not be talking about helicopter. We will be talking about fixed wing airplane. We will be talking about fixed wing airplane. So we have now introduced another new term, wing. So we have got three terms. One is airplane, another is performance, and third one is wing. Let us first see what do you understand by the term performance. Let us think, suppose you want to buy a motorbike. If I want to list out the performance of a motorbike, what we should look for? Number one, its speed. Second, its mileage, or we say fuel consumption. Third one, maneuver. Fourth, the young man will like the word pickup, how fast it can speed up. And of course, the most important thing, cost. And if I add few more, I would like to see this maintenance aspect. There could be many other performance parameters a young man will try to look for. If I now translate this into airplane, how do I translate this requirement, performance requirement of speed for an airplane? For a motorbike, we will be telling what is that speed at which I get the maximum mileage, and the fuel consumption is minimum. I can also ask myself what is the maximum speed I can run this machine, drive this motorbike. Similarly, for an airplane, I will have a similar question which I called cruise speed. That is, what is that speed at which I can efficiently cruise from one point to the another point in air? Right? We'll explain you what is the meaning of cruise. We can also think of Vmax, that is, what is the maximum speed. Then for an airplane, I can also say how fast I can a particular height. Loosely, I will be calling it as rate of climb. There will be many such questions will come to our mind as we evolve this course. Now, when coming to fuel consumption, for an aircraft, for fuel consumption, think of a motorcycle or a car. If you want to have a best fuel consumption, then there is a speed, a defined speed. At that speed, if you drive your machine, you get the best fuel consumption or the minimum fuel consumption. Similarly, for an aircraft, from fuel consumption point of view, you have best speed. Loosely, we'll talk about some ratio called lift to drag ratio. Meaning thereby, if I really want that my fuel consumption should be low, I need to fly at a particular speed which will correspond to one of the typical lift to drag ratio, which we'll be discussing as we progress. As far as maneuver is concerned, for the motorcycle, maneuver, you mean you are going straight like this, bank, the motorcycle take a sharp turn, like a young man will or a young lady will do. For an airplane, the maneuver, typically you mean I'm going like this, now I have to take a turn, I bang the airplane and take a turn, I can go, I do the pull-up, I can roll, all such things I should be able to do, and they should be pre-specified, right? And this acceleration, pickup, all are linked to this maneuver. Finally, it comes to the cost. Cost is a deciding factor, depending upon how much you can sell out and how efficiently you can sell it out, how efficiently you can use your money for a particular mission requirement. Because do not forget, motorcycle you can drive in any type of road conditions. For an airplane, depending upon its weight, depending upon type of airplane, you need additional thing called a takeoff distance. You need takeoff or landing airstrip. But you need to have, for takeoff and landing, you need to have an airstrip dedicated, made for the airplane. It needs sufficient length. It needs sufficient length of the airstrip for takeoff, and also for landing also you need sufficient length. You may have a big airplane, but you may not have an airstrip. So for you, that airplane is of no use because you cannot take it off or you cannot land, right? So whenever we're talking about performance, we'll be actually talking about these things in a systematic manner. What are those things? Let us see. Let me draw this. Let's say the aircraft is here. From here to here, we'll be talking about takeoff and warm up distance. That is, I'll be switching on the engine, doing taxiing, then I'll start increasing its speed. After certain speed, I'll start climbing. I go like this, I roll the plane, start climbing. So this phase is basically climbing. And this is where we're talking about cruise. This is where, suppose I am over an airport and there is no space on the airstrip. So what do? So I need to loiter, right? I need to stay in particular altitude and loiter till air traffic controller gives me permission to land, and then I land. I need minimum distance so that once I apply the brake, the aircraft comes to a stop. So in performance also, first thing we'll be doing the cruise performance. Second will be climb. Third, maneuver. Fourth, landing. In cruise performance, we'll be also talking about range, then endurance. Loosely, what do you mean by this? See, range is, given a tank of fuel, how long I can fly in air, right? Endurance, how long means in terms of distance, and endurance is for how long in terms of time. For a given tank of fuel, I can fly, I can be airborne. Climb, you know that for a particular height, how much time I need to climb that altitude. What is that best speed at which I should climb? Maneuver, what sort of turn rates, what sort of pull-up I can do. Landing, what is the landing distance I need to have to land the aircraft safely. So in my lecture, we'll go along with this as a guideline. But before we take up these things in detail, we'll first go into simple concept, how does an airplane fly? Airplane means fixed wing. Talking about fixed wing. One word of caution to you is that we should not try to see how a bird flies. So it's not we are going to relate how a bird flies to how does an airplane fly, a fixed wing airplane fly.